Okay, everybody uploaded their question? We got a lot to cover.
The second.
Okay. So,
But we can work together.
Yeah.
if every meeting, I always start with the last.
You do the
last
last
one. So,
Gotta hide it.
oh wait. What is that gonna look like? 5 carbon chain. 1, 2, 3, 4. Okay, 5 carbon chain. Okay, so I'm gonna have an OH here and just an O here. Is that correct? Double. Okay. So then that covers this part. What about the? One, 2, 3, 4.
Yeah, sure.
Two.
Two
Side
side chains. So I'm gonna do this.
Oh, do you want your there? That's fine, yeah.
Okay. So if I was drawing an expanded structure of this guy, how would I do that? Okay, so there's 5 carbons. 1, 2, 3, 4, 5. Okay, on that first carbon, this being my first carbon, add a double bond, O, and then O. Okay. And then on the third carbon, we have carbon, 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 and then on the fourth carbon, we have an O. Okay, and then we have to have hydrogen. So then that gives me it up there. Here. 1, 2, 3, 4 attachments. 1, 2, 3 attachments. And here, that's 1, 2, 3. So here. Remember, carbon likes to have 4 things attached to it. So it's either double bonded, if it's double bonded, it's 2 more attachments. Right? So like here, double bonded, attachments here, attachments. Right? Put your own pairs, but you don't have to.
Okay.
It's an expanded structure, it's kind of understood.
Okay.
If you did, I won't mark it. Okay, so then the chemical formula. How many carbons total? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many hydrogens? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How many did you get? 17.
Okay.
That's 3. That's 6. That's 9. That's 11. That's 13. That's 14. That's 15. 15. That's 17. That's 18. Okay, and then oxygens. The expanded structure.
Unless you add it. Well, I did that, but I wrote H, C9, H, or H for all of my O3.
That's why, because they're already connected.
H, C, I, H. So you put another H there. That's fine, yeah, because it normally if you have an acid, you have
Okay, so that would be like for the packet. I'll put an H.
Okay, questions? Concerns? Cash? Kool-Aid? Okay. So this is called crunch time. So you guys are gonna get a crunch lecture on the next couple of lectures. We're planning to do a lab today. Actually, it looks like it's more realistic. It will be tomorrow because as much as I want to.
We do lecture right now, and then we come back to the break.
We have this much packing time.
I
this
know.
much time.
Oh,
Okay, so you guys ready? So we're gonna be going over a lot of stuff pretty fast. Ask questions, keep asking questions. If it gets too fast, let me know, because I'm gonna try to put the fifth gear. Okay, you guys ready?
chapter.
We're going over chapter 7. Chapter 7. Okay. Help with your exam. Then we're going to go to chapter 9. We're done chapter 8, right? That was the line on the page. Yeah. Okay. Think about the summer class, you know, just.
Oh, faster than we wanted to.
And then they also like, I got used to teaching it a certain way. Teach me a lesson. Don't need to say anything around here. Twice a week. I'll be able to find, that way does it.
No, I feel like that's a lot of
Okay, so at this point, you guys already know how to write a chemical formula. So we're not going to start with the one that's up there. I want to give you guys something to think about. So let's do copper 3 sulfate. I'll write it on the board. Okay, so what I'd like you guys to do is write the chemical formula for copper 3 sulfate. You guys already know what the subscript and all that stuff, right? Okay. But I want you guys to give me the chemical formula for copper 3 sulfate. So, okay, anybody's gonna give it to me?
Oh, you want to read out? See you. 3. You too. off the head, honestly, so I appreciate it.
Okay, so because we know that sulfate has a -2 charge, right? And then we know that copper 3 means that it has a 3+ charge. So I'm gonna need two coppers to balance out those 2 sulfates. Okay, so you should be able to tell me how many coppers do I have in this compound? I have 2 coppers. How many sulfurs do I have in this compound? I have,
Four.
are you sure?
3.
I have 3. I have 3 sulfurs. And then how many oxygens do I have?
4.
Sure.
7.
12.
Just going down the math.
Okay, because we know that 3 times 4 is 12, right? Okay, and 3 times understood 1, 3. Okay, so if you don't know this by now, you should know this by now. Period. If you don't know this right now, plan to be in the fall. Okay, you should know this by now. Okay, we're in the 7th week. Okay, so you guys got that. Now, what I'd like you guys to do is look at your periodic table. Okay, so on your periodic table, it gives us the mass of each of the elements, right? Now, we have 2 forms of mass. We have mass when we're talking about a single compound. So that's called our atomic mass units, right? Because we're talking about at the atomic level, okay? And we also have what we call grams per mole. So those are the 2 units. I'll write them both on the board. We have atomic mass units, or AMU. We've talked about this once before, right? Or we have grams per mole. We talked about what a mole is. You guys remember what a mole is? I told you you get tattooed on your bullet. That's a butt. That's right.
Dr. Turner, I was curious about this stuff last night. I was doing that homework, it was driving me crazy. I better remember.
Okay, so those are our 2 units for mass. Okay, one allows us to change mass to quantity or quantity to mass. Okay, that's grams per mole.
Grams per mole is molar mass?
It's called molar mass. That's
Okay,
right.
guys, we're
Yes.
sure to do everything.
That's right. Molar mass. That is correct. Okay, so what I'd like you guys to do, we're going to calculate the AMU. So in other words, at the end of it, you're going to put AMU. So we know that we have 2 coppers. So if we have 2 coppers, how much does copper weigh? $63.546. Okay. Sulfur weighs how much? 32.06.
Yeah.
We're just gonna drop that 0.06. 0.06. It's not gonna make too much of a difference. Okay, and then oxygen weighs 60. Because it's 15.99999. So we can just easily round that one up to 60. Okay, so what I'd like you guys to do is to do that math. for this, you don't have to use sig figs because what you have on the periodic table, so those numbers are technically there's more numbers that follow it. So technically they still keep going. So those are just kind of rounded up already. So depending on the periodic table that you have, so you will never use the weight that you have for your molecular weight you'll never use that, or your molar weight. You'll never use that as determining sig fig. So what you'll use is the number that's given. Okay. So in this case, sig fig is full pack, obviously. Okay, so we add those together.
Yeah, I did. Yeah.
415.092. Okay, so you just learned how to calculate atomic mass. That's it. There's nothing more to it. You figure out how much of each of your different elements that you have, you add it together, and that's how much that compound weighs, which makes sense because of the law of conservation. What you put in is what you get out. Right? Okay. So you'll also hear the term formula mass versus molecular mass, right? They mean essentially the same thing, right? Formula mass is just when we talk about ionic compounds, right? We call it the formula mass because technically the way that they're going to be interacting is going to be based upon charges. So you have a whole bunch of them interacting together, but they're going to be comparable of how many that are there. I'll give you an example one time. Your light say it. Your bridge. But I'll let you do this example before we get to that. So go ahead and do the how many atoms of each of these, how many atoms of each element are in the formula unit of ammonia carbonate and calculate its atomic mass.
Yeah.
No, it was the same thing as what they used. Is all the others.
Okay. You guys have answers? Okay, so we know ammonium is NH4 plus, right? We know that because it's on the polyatomic ion table, or we already have it ingrained in our head, right? We know ammonia is NH3, ammonium has NH plus. Okay. So we also know that carbonate is CO3 2 minus charge. So that means that I need two of these guys to balance us out, right? So then I have ammonium carbonate. So that means totally I have 2 nitrogens, 8 hydrogens, 1 carbon, 3 oxygens. Everybody agree with that? Anybody disagree with that? Okay, so then I know the nitrogen weighs 14. It's like 14.001 or something like that. Okay. And then hydrogen is 0.008, 1.008 or something like that. Okay, so then 8 times 1, 8. And then I know carbon is 12.011 or something like that, so just 12. So, and then we know that oxygen is 16. So 3 times 16, 48. Add together, that's going to give you my atomic mass unit. Or we'd also call this, since this is an ionic compound, this will be its formula mass. Because what makes it an ionic compound? Yes, any guesses? What makes it an ionic compound? The charges, right? Charges coming together to balance each other out makes it an ionic compound. See, that's that common, big picture concept, right? Okay. And it's about give and take, right? Give and take. Somebody's giving, somebody's taking, right? That's how they got those charges. Okay, so this is called formula mass. Okay, so how does that differ from molecular mass? Molecular is a molecule, but it also suggests that that molecule is a single molecule that's interacting together. So that suggests covalent, right? So if it's covalently bonded, okay? So let me show you what I mean. So what if I have acetic acid? So this would be acetic acid. So find the molecular formula for this. What's that?
We're just saying.
No, we would still use aims if we're talking about the molecular. Yeah, it is exactly the same thing. They're exactly the same thing. The only thing different is that formula mass deals with ionic compounds. Molecular mass deals with covalently bonded compounds. But they mean exactly the same thing. A chemist will get upset about it, but nobody else in the world gives a fuck. It's the same way as calculus, right?
They don't, it was like, it goes wrong, we know, okay, I need to go look at this.
Yeah, so formula mass and molecular mass are calculated exactly the same way. The formula mass pertains to ionic compounds, where molecular mass pertains to covalent compounds.
Is that 3 or 5?
What's that?
After the H. The H.
It's a
3. Okay, let's figure it out.
Okay, so how many hydrogens do I have?
4.
I have 4 hydrogens. How many oxygens do I have? How many carbons do I have? So hydrogen weighs how much?
1.
Oxygen weighs how much?
16.
And carbon weighs how much? Okay, so we got 4, 32. I mean 4 plus 32 plus 24. Okay.
I know, I'm trying to figure it out.
Okay, so then that gives me my atomic mass unit. So if I wanted to scale up and I want to sit there and calculate how many grams per mole, I just put grams per mole. It's the same thing. Okay, it's just scaling up. It allows us to scale up. Okay. So when we scale up, when we use grams per mole, this is called our molar mass. Why do you think it's called molar mass? Because it's moles and mass, right? Mass, grams, and moles. That's why it's called molar mass. Okay. Oh, we're not original. We're real simple when we think about it, right? But we'll overthink it if we allow ourselves to do it. Okay, so you guys see the difference between molar mass, molecular mass, and formula mass, right? Formula mass and molecular mass are exactly the same thing, and they're going to be A and U, right? Atomic mass units.
Because I was talking about molar mass with them, and they were like, seemed a little confused.
That's why their eyes.
I thought it's because you already covered it. So.
Let's see, that's good. Now you're getting double, right? But I have to do it homeworks already. That it's already due and everything
Yeah,
like
that's
that.
why I
Because I
thought.
wanted them to push ahead.
Yeah.
Okay.
I feel like that's what I like.
So that's what was wrong with this.
Just so pretty, like, I'm sorry.
My grandma.
When that's. No, it's just really generally our other classes, and we would have like.
Yeah, sure.
She's adorable, the hydrogen. They can be bright.
Oh, that's great. I have tomorrow. They gave us a break today, so it's not due today, it's due tomorrow. But of course I. And my class.
You just started.
And then I actually really have to. Okay. So I'm feeling it. Okay, so you guys kind of get it, right?
Yeah.
Okay, good. So let's move forward.
No, it was like part of her birthday. So she sure did.
Okay.
Whatever she don't like.
So when we talk about molecular formula, we're talking about covalently bonded things like carbon dioxide. Okay, this is just an example of that. You guys can look at it on your time, right? So we just kind of did it over there. Okay, so when we talk about formula mass, we're talking about ionic. Okay, so here, this is calculating the ammonium nitrate. We've already done it, right? We're kind of good to go. You guys are. Now, I will say one thing, right? Here, they just use units. Instead of saying atomic mass units, they abbreviate it as just units. That's okay. Okay. And you'll see the book, it'll actually interchange both of those. Okay. Okay, we talked about Avogadro's number, the mole. We know that 1 mole is equal to 6.022 times 10 to the 23rd, right? They get lazy, they put 6.02, right?
That's why some of the math is a little off.
That's right.
Oh, yeah, it's
So
really
it should be
very simple.
6.022 times 10 to the 23rd.
Oh.
And if you're a little off, you usually compensate when you do your sig figs, usually works out. Okay, again, this is based upon carbon 12, right? So when they actually looked at carbon 12, they took 12 grams of carbon and then they actually counted how many molecules or how many atoms of carbon was actually there, right? They did it by radio X-rays. Use X-rays to determine it. But they counted and they ended up getting 6.022 times 10 to the 23rd. They got that consistent. Okay, so it's based upon carbon 12. Now, 6.022 times 10 to the 23rd is also called Avogadro's number. Right? A lot of people say Avogadro's number, or they'll call it Avogadro's constant. Okay. Again, it just means the same thing as an ounce. I mean, not an ounce, a dozen ounce. Sorry, thinking about the wrong thing right now. So a dozen. So how many are in a dozen? 12. So we know that anytime anybody talks about a dozen, they mean 12, right? Okay, and it doesn't matter what it is. It could be a dozen donuts, dozen eggs, dozen girlfriends, dozen mistresses, dozen tacos, right? It doesn't matter. That's the same thing that we're talking about with a mole. 1 mole is always going to be 6.022 times 10 to the 23rd. And we know that that is going to be quantity, right? That's how many we have, right? Quantity. That's different from mass, right? Because you're 1 person, but you weigh whatever you weigh, right? So I'm 1 person, I weigh 220 pounds. Okay, so my mass is 220 pounds, but I'm 1 person. I'm quantity of 1, right? You guys see the difference between them. Okay, so that's going to be important. You need to understand the difference between quantity and mass. Don't mistake them for the same thing, because they're not the same thing. When we do chemical equations, it's based upon what? Quantity versus based upon mass.
I just wanted to see what you did.
So just to be sure, right? Just to be sure. Let's balance this chemical equation because you guys have forgot how to balance chemical equations, right?
This is great.
So let's say we have
Oh, yeah, that's right. How do I see? Yeah, it's like 2.
never ends.
Yeah,
Did
H2,
you guys see? Oh, let me-
O2.
sorry. I'm like, you guys see it, don't you?
Yeah.
Not
I
that we-
thought,
Oh, you
Is that a
add two
double?
next to the H in the beginning.
Where's the Yeah.
Where's the I for liquid?
What? Yeah, it's an L. Where? Is it an
Look at that,
L?
look at that.
I think it's a dou- Oh, it's an L. It's in parentheses.
Oh, shit.
Okay, so how can I balance it out?
Oh my goodness.
Hold on, let's work on it.
right into the 2.
Put a 2 in front of the H2 on the other side, and put a 2 on the other side,
Here?
and a 2 on the H2O. No. Oh, no, wait. No.
Put a 4 in the beginning and a 2 right there. Yeah, put a
What am I
4.
putting 2?
Put a 4 right there.
I'm putting a 4 here.
Yeah. And I think that should be.
It's not balanced.
They put a two. You put a two in front of the, in front of the H. right there?
Two in front of here.
Well, there,
No, you said two in front of here.
Yes.
Two in front of
And
here.
four right there.
And four right here.
yep. There you go.
And then,
4, 4, 8. Two.
Balanced. Okay.
wait, hold on, give me a second.
Okay.
You did it on purpose, eh?
But can you write them down?
Oh, like the HO. Oh, can you put the HO? The HO, like light it up. So we can add how many there is. That's what you're saying, right? Oh. No. No. That's all I'm asking.
You said it's not lined up.
No,
Like count them.
count them out, like count them out, HO. That makes more sense.
That doesn't even matter, it can't work.
That's right. It won't work, right? Okay, so first off, we know that this isn't gonna work for us, right? Because there's no way that we can sit there and get this separated because we have the water actually flying here. So initially I had it like this. So if it was like this,
Oh, sorry.
No, yeah.
it's very balanced, right? Now, but if we look at this, right, it's supposed to be quantity, okay? Quantity tells me that for every one hydrogen peroxide, I have one hydrogen gas made and one oxygen gas. Okay? So it's a 1 to 1 to 1. Is that mass? Did I say anything about mass? So I know that it's quantity. So when I look at the chemical equation, it's based upon quantity, right? Okay? Do you have my sangria recipe?
Yes.
You do?
For real?
Yeah.
To make wine, sangria?
Sangria.
I need it.
You need the sangria recipe? Now, you
For
gonna
the
tell them my
exam.
sangria recipe? You have it on you? Okay, bring it tomorrow. if you can. Okay, bring it tomorrow. She'll bring the sangria recipe tomorrow. Okay, now, the point is that if we make sangria, it's gonna be made based upon quantity. You know, we take that bottle of wine, we fortify it with some vodka, right? That's the secret. Don't let anybody know. It's a little secret, okay? So you feel really good after you have my sangria. Now, you want the fruit to soak in the vodka, so you sit there and you put your fruit, but you're putting quantities of fruit. You're not taking mass of fruit. You're taking quantities, okay? It's based upon quantity, okay? Because we know that an apple is gonna weigh different than a grape, right? So we want to base it upon quantity, not based upon mass, because we want so many grapes in there. And we want so many kind of pieces of apples, right? So that's quantity. Okay, you guys see the difference between quantity and mass. Don't make that mistake on the exam. Okay. Okay, so this is the reason why we need to have it based on quantity. That's also part of the reason why we need to sit there and have ways to change it from grams, which is mass, to moles, quantity. So this is used as a conversion factor for us. Okay, you guys got that? Now, you notice that I'm stressing it. You see the stressing going on because, yeah, because it is the most commonly mistake ever. Everybody, you know, for some reason, you don't understand that concept of quantity, right? How many people there are versus how much they weigh, right? Because have you seen those signs in the elevator, right? You'll have a sign that says one sign, which is an old sign that'll say quantity. Or you can only have 30 people in this elevator. right? And then another one that says mass, right?
Like the weight.
The weight, exactly, right? Exactly, the weight capacity, right? And so they contradict each other because if you get a whole bunch of big people in the elevator, you're gonna exceed that weight, right?
Right. And it won't let you go.
Exactly, and you won't be able to move anywhere, exactly, yeah. So
That happened to
quantity,
me.
mass, right?
I got stuck in the light. Oh.
There wasn't people.
Was it chunky?
I don't even remember. I was little. I was by myself. I got stuck in.
Well, there's why I don't like elevators because it's final destination.
Oh my god. I hate driving behind like trying to get the house.
Oh, yeah, yeah, like anything that has anything.
Okay. So a sample consisting of 0.25 moles of ammonia. How many ammonia molecules is this? Okay,
I don't know. So.
what's the chemical formula for ammonia? Take a moment behind you. We just talked about ammonia, which is what? NH3 is ammonia, right? So those again, those little mistakes that we make on exams, right? Believe me, I've seen them. Okay, so if we have 0.25 moles, how many molecules is that? What would I use? What would I start off with? Coming over
You
here.
have to write out NH3, and then you have to figure out like maybe the.
Do I even want mass, right? Have you even talked about mass? Does it say I want mass?
No,
What
you
does it
want
say I want?
atoms.
I want quantity. I want quantity.
We want molecules.
What was that?
We want molecules.
I want molecules, right? So that's gonna be quantity. So what am I gonna use? What did I tell you to tattoo on your butts?
The Avogadro.
I'm gonna use Avogadro's number, right? I'm gonna use Avogadro's number. Okay, so we know that Avogadro's number is 1 mole per 6.022 times 10 to the 23rd of whatever we want. The atoms, it could be electrons, it could be molecules. Now, the key is that we want to make sure that we don't mistake molecules for moles because they're not the same thing. How many people did that?
Almost.
They're not the same thing, guys. Man, I spent my whole high school career doing that, and I'm like, this does not make sense. They're not the same thing. Okay, molecules and moles are not the same thing. Okay, you guys know what a molecule is, and you know what a mole is. Mole is just quantity, right? Like it does. Okay, so how would I use this? And this, where would I start off with? What is my starting?
With 0.25 moles.
Okay, so I want to be organized. So I'm going to start with 0.25 moles of ammonia. Okay, how can I use this? Am I just going to use it the way it is? No, what am I going to do? I'm going to invert, right? Flip it over. So I'm going to put 6.022 times 10 to the 23rd molecules of ammonia over 1 mole. No, it could be, okay, wait. Is a dozen always eggs? No.
Oh, it can be whatever you want.
It could be whatever you want. It could be your boyfriend. It could be your girlfriend. It could be both your boyfriend and your girlfriend, right? It doesn't matter. It could be whatever you want it to be. A mole can be anything that you want it to be. It could be electrons. It could be atoms. It could be
Like a mole of that substance, right?
yeah, a mole of Vaseline, right? So that means you have 6.00222 times 10 to the 23rd of Vaseline bonds, right? It could be whatever you want it to be, right?
It's just another word,
I get
like
it.
a substitute for quantity, it's just a quantity
It's
of.
quantity of something,
yeah.
yeah. Okay,
I get it.
so moles cancel out and we're left with our quantity, right? So that's what, 1/4? So it's 1.5. And there's 2 sig figs, so it'll be 1.5 times 10 to the 20. Okay? Questions? Concerns? Now, do you guys understand? What does moles mean?
Quantity.
Quantity, right? If you think about a dozen, it means the same thing like a dozen, just not the same number, right? Right? Okay.
Oh, it tells you the answer. The E means 10. So it'd be 1.5 times 10 to the 23rd. And I'm like, 20 got it wrong. Yeah, like, don't you look at your phone?
Question on it, so they both equal quantities, why do we pay more for them? Just for
What do you mean by they both equal quantity? Mole equals quantity. How many does it? Doesn't a dozen mean 12?
Yes.
Right? It's like a quick term for a dozen. Because we know if we talk about 12, you know, rather than saying 12. it's actually 12. Because that's what we're trying to find out. Ammonia is a molecule. That's right. Yeah. If I said, how many atoms are in ammonia, right? Because then you have to give you atoms, so that means you have to.
Let me write it down. What I'm-
The fact that we're talking
Yeah, we
about
tried doing it on Google
a
Translate.
nitrogen
and I couldn't get it.
and a hydrogen,
Say it again.
right? Sometimes you do this with how many atoms in one. So how many nitrogen atoms are in 0.25 moles of ammonia? Okay, so that's our question. I'll write it up here so you guys can see. This is driving me crazy. They need another thing over here so that I can.
Yeah. You're getting your steps in.
I know.
Maybe the iPad.
That's actually a good idea.
No,
I
but then
wonder-
you have it in your hand.
Huh?
You can leave it on the
Wait, can
desk.
you disconnect
Oh, I
it?
guess.
Oh, but I think it's connected to like the whole.
Yeah, I think it's connected. So
Just say like
we're gonna change.
Don't say like an H.
no, so you say like
Say it.
Good look at it.
I still will.
No, don't say like.
Don't pronounce the H.
No,
I'm
but
not.
it's-
Okay, go
Like,
slowly.
I can't spell it.
No, guys, she said let me spell it, but we can't see.
There's like 3 letters more in Arabic that you can't say.
Damn.
Spanish it is. Say your cousin to say it. Because I'm not saying it like really. Because I mean, doesn't it have like extra?
Wait, what does it say?
Yeah.
So was that about?
Okay, so because we're talking about a molecule, right? We know ammonia is a molecule. right? Because the definition of a molecule, the general definition of a molecule is what? The general definition of a molecule is what? It goes back to the very first week. Come on.
Yeah.
The very, very first week.
It's a molecule have two or more elements.
Two or more atoms. Right? You don't have to be the same. They can be the same or they can be different, right? So molecules is just two or more, right? Is this two or more? Yes, that's right. It is two or more. Good job. Okay. So. Okay, so we know that there's two or more atoms in here, right? So if we take a look at ammonia, right? Ammonia has, for every one thing of ammonia, how many atoms of nitrogen do we have?
One.
We have one. So it's 1 to 1. So for every one molecule
The one.
of ammonia,
Oh,
Oh.
it's one nitrogen.
we have one atom of nitrogen. Is that true?
Yes.
Okay, so then, in that case, molecules cancel out, and then we get our number, which is 1.5 times 10 to the 23rd atoms of nitrogen. Okay. Okay, so if I was talking about hydrogen, how's that going to differ?
Nothing in the middle, how many atoms of nitrogen?
Okay, so then how many atoms of hydrogen are in ammonia?
3. Yes.
Why do you do that? How do you say you're gonna make it up?
What was that?
Why do you do that? You always make up someone thinking we're already
He
double.
doesn't want to wrong. They're like,
Well, we were right earlier about
I don't know what you guys are talking about.
why?
If you look at us like we're
I'm
wrong.
not sure.
Because last time.
And we were right. You said it.
No, I taught some kids.
No,
how to
I
say
do it because you need to be
This is
confident,
next one,
right?
we're not those
If you're
kids.
not confident, that's gonna be a problem, right?
Yeah.
it. And then-
Uh-huh.
And then
They
they told us
Of any three.
the kids would tell
It's that concept of believing in yourself. Right? So it'll be 3 times that amount, right? Which is,
He's like, I'm scarred.
okay, now do you see the distinction, right? Because here we're talking about atoms. Earlier, we were talking about molecules. You know the difference between atoms and molecules, right?
One and then molecules.
That's right. A molecule could be 2 or more, right? There we go. We're getting there, right? We're getting there. You guys are remembering the stuff that you guys did in the very beginning, right? Okay, so you guys ready to move on?
Yeah, let me just.
Hold on, let me take a picture.
I understand now.
Okay, so if we have 0.25 moles of ammonia, how much is that gonna weigh?
I don't know.
I'm scared. I don't know.
We would use the atomic mass unit, or we would use, in this case, if we're using moles, we would be using atomic mass units, or we'd be using molar mass, so we'd be using grams per mole. Okay, so
That's all we wanted it for. Not to offend people.
no, what am I gonna start out with?
0.25.
0.25. What's gonna be next?
Of NH3.
Come on, you're there, come on. So we need to calculate the molar mass. So how would I calculate the molar mass? So we have one nitrogen, which weighs 1 times 14. 3 hydrogens. 3 times 1. 17 grams per mole, right? Because we're talking about molar mass. Okay, so can I use this? Yeah. Okay, so how would I use it? What's going to be on top? What's going to be on bottom? Because I want the mass or the weight, I'm going to put grams on top, and I'm going to put moles on the bottom because that's what I want to get rid of. Okay. So four point 5. So it's just 6 base, so it means 4.
Don't emphasize the H. Oh,
So technically 4.25. But there's 2 sig figs here, right? That's exactly 5. There's nothing following it. So we use this number. So 4.5. Okay. That's right. So it's just conversions. It's the stuff that we learned in the 3rd chapter. Oh my God, yes, right? So now we're actually starting to use all the stuff that we learned before, right? Stuff that you guys thought you would never use, right?
I was like, I dumped it out.
Uh-huh. Okay, so you guys ready to move forward? Well, we're gonna take a 10-minute break, or 15-minute break. I'll see you guys back here at 10:10. I will be starting at 10:10. Okay, so should be able to see this page right now. Right? So when you guys finish your page itself, there's not a submit. You just have to let me know, just give me, copy the link and then submit that link. Okay. We're out. And then your parity, you need to upload, one person will need to upload the parity. And then one person will need to upload the presentation. Yeah, just one. Okay. And I thought this was already up for you guys, but
25 minutes total.
25 minutes total. What?
We're not physically presenting in class, are we?
You're physically presenting.
Okay, so that's why I don't know why I keep hearing no and yes.
We'll go over that again.
So then you're
20
just gonna
minutes
watch
is
your
nothing. We
period.
have 4 or 5 people.
25 minutes is just the presentation and the questions, and then the 2 to 3 minutes is separate?
The
Or
2 to 3 minutes is your parity.
does that include, like, is
Within
that
the 20
included
minutes.
within the 20 minutes or not?
No, yeah,
You're gonna have us talking like robots up there. And today we, no, it's like.
So we don't, do we need to be in the video?
you just
Can I
got
take
changed.
that? No, so-
So the presentations are the 26th, right?
The presentation is on Monday.
Oh, the 25th.
Just like the.
Okay, are there any questions? Since you guys are the only one that's here, you're representing your groups. Yeah, good. Okay, so.
It was the last one. We didn't use a. So I just marked that.
Well, like, that's why I tell you that.
Okay, here's your question. Follow me.
At first. Throwing like that form code, when you start throwing those in there. Like the 3, 6, 7, 5, what is that question? Like, more code?
Okay.
Yeah. When you start throwing that, I literally don't know what the hell it is.
It's the same thing. It's just means this is a really big number, right? Or would you could also, if you really wanted to, you could write it all out. with
And
all
I
those
have
zeros.
actually, just because I get so confused.
Yes.
I'm telling you.
For this, I put this up here. So like, it kind of shows you where you need to go. So if you're in molecules, you have to go to molecules and moles. Depending where you are. So if you're in mass, you go this way. Like the arrows go like either way. Yeah. And that, this is all about this number right here. To moles to. And molar mass, their mass. More like a little visual aid, so you know where to go. I'll be there from 12 to 2. Well, I go on at 11. You guys will be out.
So what was that to?
Like I could try stats, but stats is not my favorite. Yeah, well, it's like, I just don't really, I'm not really used to stats. Will you take the salad?
Actually, this sounds super
You use some I do not agree.
But you know what he did? He averaged it out to, no, she's not the teacher, so he averaged it out to 60.
The 6% of B?
Yeah. Yeah, because he's not good though.
You know, I did great on a massive group.
He quit after that, like.
Oh, you think he enrolled the teacher? Yeah.
No, but then no.
My sister took him for comp 1, and yeah, he was not the best teacher.
That's as hard.
He would go through like 3 chapters every day.
Yeah, pass it. I didn't even need to take it.
You gotta take stats.
Oh my God, yeah.
Yeah, that was like 3 years ago. Thankfully.
I know Fresno State, I know Fresno State. Anybody wants to university, you have to take stats.
You just need a transfer book. Some stats for you.
Cause the school I called, I don't know if it's different on the East Coast, but. What I call it.
I mean, I've taken all the concepts. Yeah. So that covers some math.
They said only our age?
I think that's just like what I call it. Yeah.
But you have to make sure it's transferable. So it's like national before, right here. But I don't think that's transferable. I'm just gonna change it.
When I called, he said I was like.
The algebra class here.
Yeah.
Oh, okay.
That probably was.
Like the math 64.
Yeah, I think so. Not to Fresno.
Oh.
I'm talking about the school on the East Coast.
Oh, okay, okay.
Yeah.
Yeah. Well, that's cool. They all don't accept it. 'Cause I know some universities won't accept like the algebra class.
So, I want to see like if my church is.
Yeah. Yeah, what's the point of taking the classes here? You won't count.
I was trying to see what number you got, just so I don't have to do that. How did you find
Okay, you guys got it?
almost?
Good.
Okay. We'll figure it out.
Okay, so what's my given?
Your given is the
3.75
times 10 to the 17.
times 10 to 17.
So yeah.
Molecules of what?
Copper sulfide.
Okay, what is copper 2 sulfide? look? Okay. Okay. And then what am I going to do? Okay, so we said 1 mole of copper sulfide 3.0 times 10 to the third. Molecules. Copper. Five, 4, 6. Sulfur.
The line
Yeah.
I would, it's kind of the answer, and then I would test what you have to say. I'm gonna press the whole entrance. Says what 5.5.
Okay, everybody got this problem, right?
Yeah.
Okay. Okay, so that means that I can go from molecules to mass, right? But I have to use two different steps. I have to use Avogadro's number, and I have to use molar mass. Okay? Okay, questions, concerns, Cash, Kool-Aid? Okay. So there were some questions about your projects. Let me get there. So your projects is 20-minute presentation, right? That does not include your parody, right? That's just your presentation, okay? And then you have 5 minutes of question and answer.
Oh, that's separate.
That's separate. That's not part of that 20. So that's a total of 25. Plus you have your parody too, right? Yes.
For the 2,000 pages, it's like a normal.
It's like a normal document, but you should have figures in there, because if you don't have figures, I'm really pissed off and I fall asleep on it. And if I fall asleep on it, it's like getting a zero. Right? Like figures, pictures,
Graphs,
graphs, figures, right?
graphs, charts.
So for the pictures.
Images, right? So those are called figures. And you want to make sure that they're labeled so that I understand what they are and their relevance. Don't have, I know there's a tendency of putting dogs and cats in everything, right? Unless there isn't any significance to that dog or cat, they should not be in there. You understand what I'm saying? So, yeah, so there needs to be significance of it, right? So like, for instance, I don't mind somebody putting a mole when they're talking about moles, right? Because, you know, most people, when you talk about moles, the first thing they think of is what? A mole, right? Okay, so, or a mole, or physically a mole in your face or something. So those are the two things I see, right? So in that context, that's, you know, it's cute. You can do stuff like that. That's fine. But if you just have a cat or dog, just have a cat or dog in it, don't do it.
Well, we could put a cat if it has a cat.
Oh, so your cat.
A cat eye on, yes, you can use it like that, exactly. Help people remember things, yes, good job. Okay, does that make sense? Okay, and you guys, I mean, you guys are complaining about 20 minutes. 20 minutes will go like this, and if you practice, when you practice, if you're over your 20 minutes, right? If you're a little over, it's okay, right? But if you're like 30 minutes or 40 minutes, which I will cut you off in a heartbeat, right? You'll start getting into deep, and you're gonna get deducted for every 2, I'll say every 2 minutes that you're over, we'll deduct some points. And we'll see. So, and if you're under, you'll get deducted. Yeah, for every minute that you're under,
I thought you
you'll
said
get
every 2
deducted
minutes.
points. Yes.
Every 2 minutes.
No, for every 2
No,
minutes
every-
that you're over,
Wow.
but every minute that you're under,
Ask the question, can we do a confused instead of a hot one?
I start the timer when the first person starts talking. Okay, no pressure.
A lot of pressure. Can we do a Kahoot, so like instead of them asking questions, can we do a Kahoot? Like that'll be the question, the 5 minutes?
No,
No?
yeah, so, but yes and no, you can do a Kahoot,
Could we have a
but
Kahoot
that
and then
isn't part of
ask
your
questions
question.
too?
Yes, that isn't part of your question and answer session. The question and answer is for the class asking you questions.
Okay, but we could have a Kahoot.
Do you understand?
Yes, could we have like a Kahoot and then ask us question afterwards
Yes,
to complete the 5 minutes?
no,
No, it doesn't count.
Might as
Can
well
the
not
Kahoot
be
be
like
part of the
part of
presentation? Can the Kahoot be part of the presentation?
yes, the
At the end.
Kahoot can be part of the presentation, but it cannot occupy more than 5 minutes of your presentation.
So that's what we do, 15 minutes, that's 5 minutes.
Yeah, you just said it can't occupy more than 5
5
minutes.
minutes. That's right, exactly.
Okay, but then you'll find out because you guys have a lot to say. You won't realize it. And then when you go over, I'm gonna be deducting one.
But we just have this bathroom review the answers are the same.
Exactly.
I don't know what you just said, but
See?
But I did, that was like.
okay,
Got this.
okay. Well, you know, you got this. Okay. Okay. Any other questions? Good, good. Okay, so let's finish this lecture.
I have extra credit for this one.
Never used to be.
I know, that's a lot of gas wasted too.
Extra
You
point.
know
for
what? I
every-
got
for
COVID.
every
That's not fair.
money.
For a mile. That's like 22 miles from me.
So you're definitely living in a fantasy right now. You can keep living there. It's okay. Just stay there. It ain't gonna help you.
Oh, and that
Yeah.
fantasy, I have an A+ in there.
Oh, you have, in your fantasy, you have an A+.
Yeah.
110%.
Now you need to try to bring that to reality, right?
Damn.
Okay.
That's gonna be hard.
So we've talked about molar mass. You guys know what molar mass. Again, it's based upon carbon 12. What is carbon 12 again? Carbon 12. It is an isotope of carbon. That's right. It is the most abundant isotope that's found in nature. It is found in almost everything, right? Or say every living, right? Because that's what makes, one of the things that make you living is the fact that you have carbon, right? Okay, so calculate the molar mass of calcium chloride. Good piece of cake, right? Okay. So what is the chemical formula for calcium chloride?
Yes.
CAF. Back to the basic. I wanted you to be able to flow both ways, right? You should be able to go any way you want to, right? Okay, so we have calcium chloride, right? So what is the molar mass of calcium chloride? 40. How did you calculate?
So on the period.
Are you secure on the table?
Wait, what?
Okay, so let's do it. So we have calcium. Calcium weighs how much?
40.08.
Calcium weighs 40. Okay. And then chloride, and we have two of them, 2
Yeah.
times 19.
Yes.
So this molar mass is going to be,
58.
and the units,
G.
Oh, no, different first.
okay, right? So we know since we're talking about molar mass, we should have moles and a mass, right? Molar mass, okay? Now, let's say we have calcium chloride, right? And we have 39.02 grams of calcium fluoride. How many moles? How many atoms? Of fluoride. Yep. Okay. Okay, so what do I need to do? Convert? Okay, so how am I gonna convert? So what am I gonna start off with?
So 3 point.
39.02 grams. Okay, 2. Okay, and then? Add grams, right? I have grams, we're starting with grams. So I should be using something that has grams in it. What has grams in it? The molar mass. So what is the molar mass? 1 mole over 1 mole over gram over 1 gram.
Oh.
Isn't it over the
It's,
70,
What was that?
the 78?
78. Because we're talking about calcium fluoride. We know what we're talking about. We know the molar mass of calcium fluoride because we can find it from the periodic table. So if I'm given grams, I know I need to change from grams to moles, right? So you don't forget that step. You hit it again, right? Okay, so then this allows us to calculate the number of moles, right? Isn't that part of the question? Don't we want the number of moles?
Yeah.
Okay, so this gives me how many moles? Math for me.
0.5?
What was it?
0.5? Or you're supposed to divide it, right? So it'll be
0.5. How many sig figs should I have?
2. Oh, 3.
4. I should have 4 sig figs.
So it's gonna be
0.
0.5002.
You said 0, 0, what?
2.
2. Right? This here is 4 sig figs, right? 2 moles of calcium chloride. Okay, are we done?
No, you keep your atoms, right?
We need to figure out the number of atoms of
Fluoride.
fluoride. How would I do that? Can I erase this part here in the middle? Everybody got this part down?
Yeah.
Not take a picture. We're gonna do what?
Avocado.
We're gonna use Avogadro's number. Okay, so we're gonna start with our 0.5002 moles of calcium fluoride. And how am I gonna use Avogadro's number?
Maybe the 6.02. Oh, no, wait, I'm wrong. Never mind.
Yeah, right. that's
Oh,
what-
yeah,
Yeah.
it's
What's going on top?
6.02 times.
Okay, 6.022 times 10 to the
Power of 23.
power of 23. And that is gonna be atoms of fluoride, right? Okay, are you sure?
Don't we put the calcium fluoride? Oh, no.
We have to put calcium fluoride first, right?
Yeah.
Oh, okay, so let's take a step back. So that's 6.022 times 10 to the 23rd calcium fluoride. So that's 1 mole of calcium fluoride. Molecules, right? Okay, so how would I get rid of molecules? I want atoms. So for every 1 molecule of calcium fluoride, how many atoms of fluoride do I have? Okay, so for every 1 molecule of calcium fluoride, I have 2, right? Because CaF2, right? That's 1 of those. If I have 1 of those, I have 2 fluorides. Atoms of F. Okay, so then my answer should be do the math, put your calculator. When in doubt, check me out.
I got 6.0244.
Yeah, me too. Yeah.
Yeah.
Two,
So
four,
like,
four.
it was.
6.0244.
Maybe I calculated.
So you ever put the 4? How many sig figs should I have? I should have 4. 1, 2, 3, 4. And that 4 is less than 5, right? Okay. Questions? Concerns? Cash? Kool-Aid?
Gas card.
Yes. Oh, yeah. No, or electric vehicle. I'll take electric vehicle.
Oh,
Anybody
yeah,
wants
what?
to-
Yes, me too. So $5 is the car.
Okay,
Charge the car.
so, no problems, right? Everybody's got this?
Oh, yeah.
You own it?
Taking it back to you.
I got the same answer, but this way it gave me that form. Because I did.
Okay.
It makes more sense like all together.
Yeah. Yeah.
All the pieces are coming together.
Yeah, because like, when I first came to class, I was like, whoa, he's crazy. Because he put so many layers and layers and layers, and I was like, oh. I didn't get it.
Okay, so this is the thing that, again, as a student, I didn't quite understand, right? So when we talk about 1 mole, right? 1 mole of, let's say, of apples is going to be different than 1 mole of grapes, right? They're going to be the same quantity, right? So if we talk about a mole of apples, that's going to be how many apples? 1 mole of apples is going to be how many apples? 6.022 times 10 to the 23rd, right? If I talk about 1 mole of grapes, that's going to be how many grapes? Okay, now are they going to weigh the same?
No.
No, right? So we know that a mole of apples is going to be heavier than a mole of grapes, significantly heavier, right? Because an apple is this big and a grape is only this big, right? Okay, so that's the same thing that we see here. That's what's being shown here. That's the importance of this, right? It's just showing you that if you have 1 mole of substance, it's going to weigh differently depending on what that substance is. Does that make sense? Okay, it's kind of like saying there's 1 of you and there's 1 of me, right? We weigh differently, right? She weighs much less than I weigh, right? Okay. So we're carrying out a lab reaction that requires 0.0360 moles of barium chloride. How many grams of the compound do you measure out? It's a piece of cake, and you guys are doing this over, right? So where am I going to start? With what I'm given. So what am I getting? 0.0360 moles. Barium chloride. Okay, that's got 3. Okay, so what am I going to do? Get the molar mass. That's good. Okay, so we know that barium weighs how much? Okay, chloride weighs how much? Add them together. Okay. You guys can correct me if I'm wrong. Okay, so we know that this is barium chloride. What am I going to do with it? Now that I got the molar mass, what am I going to do?
You gotta get rid of the.
So I'm going to put moles on the bottom. And I'm going to put the grams on top. Okay. What's that? Oh. and they will get solar.
That's 208.236, right?
Yeah.
Same ground. I don't know. So, might be different. Periodic tables. Questions? Oh, let me- Okay,
That's it. Is that one step?
yeah, we just gotta do the calculation. What was the
Isn't it
calculation?
just 2.4?
So 22.4.
22.5. 0.5.
22.505 grams. So how many sig figs do I have?
I got 7.4.
That could have been calculated wrong.
Oh, okay.
Sorry.
7.496.
What are those?
7.4. And how many sig figs do I have? 4. Sure. 1, 2, 3. These are space holders, is that right?
This
I have
is
three-
7.50.
Okay, 7.50 grams. There's- Questions? Concerns, cash, Kool-Aid?
No.
Okay, good. No questions? Okay, so this just basically shows us that if we're starting off with units, right, or quantity, we can go to moles, then we can go to mass. If we're starting off with mass, we can go to moles, and then we can go to quantity, right? And it just shows you what you'll need to get there, right? Molar mass, or MM stands for molar mass, and NA stands for Avogadro. This is just showing you exactly the same thing in a different fashion. Okay, so we just wanted you to remember it. Okay, so determine the mass in grams of 3.2 times 10 to the 24th molecules of sulfur tetrafluoride. Don't have that on. Okay, so how am I going to do that? I need to write together. Good. Takes the short time. Okay, so we have molecules of, what is the chemical formula for that?
SF4. SF4.
And you said S4F?
SF4.
Okay, SF4, okay. Am I done?
No.
I need the molar mass, okay. So I have 1 S and then 4 F. Okay, so what is the mass of chlorine? 19 times 4. Okay, and then sulfur. Grams per mole. Okay, how am I going to use that? Where am I going to use it? Okay, so what do I need to use first? How am I getting it? So you're going to give me there?
We're gonna do one more.
So I'm going to do 1 mole. Over 6.022 times 10 to the 23rd molecules. Okay. Am I done? No. What are we going to do next? Okay, the molar mass. How am I going to use it?
One more over.
So final 8 grams. 4. 4. So that's equal. Got me. You say it's
5, 7, times 10.
depends on what.
48, but let us redo the math because we got 2 different answers.
Like, we 10 to the 48, I can guarantee you that.
Maybe it did the, maybe.
So this guy, you need to use your brains. So you want to put 3.2 times 10 to the 4th. That should be right. And then division, it should be 6.02 times 4th. Put that in parentheses. Five seventy. 570.
5, 7. And I did, yeah.
Okay. How you guys doing over here? I heard you're a lot over here. I want to hear from you guys too. Okay.
Good. Oh, I wasn't.
Okay.
I was a bit something. I think I put times and then did no times 10, 24. And I was like.
Yeah, you actually, it was the 10 times to the 23rd multiplied by action. So. Okay. Okay, so the next thing we're going to be talking about is called percent composition mass. So percent composition mass basically means that we're looking at part over the whole. You guys did fractions before? So let's talk about fractions. I know you guys love it so much, right? Real quick. My girlfriend would go in tears when we start talking about fractions.
Oh.
Start crying. No, can't cry. Chemistry, no crying.
Did you even take chemistry if you cried?
What was that?
No.
Yeah, that's not real chemistry. That's kind of
What?
Okay, so when we talk about parts over a whole, so we have a pizza, right? A pizza pie, right? So that pizza pie would be a whole pizza pie, right? Now, I get greedy sometimes. I want to eat a whole pizza by myself, right? But we can't. Usually when we have company over, we've got to share, right? So we cut it up in slices. Okay, I cut this pizza up into how many slices?
8 slices.
Okay, so this is 8 slices, okay, all together. So at the bottom, we have 8. So right now, the pizza is not eaten at all, okay? How many slices are on there? 8. 8 over 8 is going to equal to what?
1.
1. We know that, right? Okay. Now, if I eat 1 pizza slice, then how much of the pie have I eaten? 1 8. So if we take a look at this, right? 1 pizza slice out of 8 slices have been eaten. So that would be the part over the whole, the part that has been eaten over the whole thing. Does that make sense?
Yeah.
Okay, so when we do percent, it's essentially looking at the same thing, right? Because we're saying we have 100%. This is 100% of the pizza, right? How much did I eat of the pizza in terms of percentage?
I was gonna say 10%.
Oh, I set you guys up.
You did.
Oh, I set you up.
So you do 8. Well, yeah.
It's 1/8, right? So
Yeah.
1/8. 1 divided by 8 is what? 0.125, right? Now, if we get percentage, we multiply that by 100. Right? So then it would be 12.5% is what we ate. Okay? 12, right? Okay. Do you guys see that?
Yeah.
Okay, so that's percentage. That's part over the whole times 100. So that's going to give us our percent composition. So when we talk about a compound, everybody understand this, right? We're comfortable with this. Okay, so if we're talking about a compound, we're talking about parts over the whole. So if we're talking about our calcium fluoride, our CF2, and we're talking about mass, percent mass. So we know that calcium weighs how much? And how many calciums do we have? Calcium fluoride.
Also was 40.
So we know that it weighs 40, right? And then we have 1 times 40. And then fluoride, we have how much?
19.
We have 2, 2 times 19. Right? So this is 8, 40. So we get 78. So the total mass is 78. Total molar mass, right? Okay, so if we want to know how much chloride is in our calcium fluoride, what do I need to do? I want the percent mass of calcium fluoride, percent mass of fluoride in our calcium fluoride.
So the 38 over 78.
What was it?
38 over 78.
38 over 78, because it's the part, so we're just looking at the fluoride, right? So it'll be 38 divided by 78 times 100. So that would be part over the whole times 100. So if I did this, what am I gonna get?
48.7.
48.7%?
Yeah.
Okay, so if I have 48.7% fluoride in my calcium fluoride, how much of it must be fluoride?
Yeah.
100 minus 48.7, gonna be 51.3% calcium, right? Is
51.3.
Yeah.
that better?
Yeah.
You guys get it?
Yeah.
Okay, so percent mass lets us know how much of one element we have in our total compound. Now this becomes valuable when we're trying to do analysis, certain types of analysis, because usually we're looking at one element, one atom, one type of atom, because we can analyze what that one type of atom looks like in a compound. Okay. Questions? Concerns? Now you want to use this, right? Now, I'm actually going to show you this real quick, right? So they got the same, actually, they got the same number that we got, sort of, but they did 4 sig figs. It doesn't matter because again, you're using your periodic table. You can use 3 sig figs, you can use 2 sig figs. You know, if you're really hard up, you could probably get away with using 1 sig fig, right? Because you're using your periodic table. You're never going to use that to determine your significant features. Okay, so in other words, you can go out there as far as you want to go out for a percent composition, unless you're given something, right? Then it's going to be different. Not sure. Okay, calculate the percent composition by mass of aluminum sulfate. They want you to calculate the percent composition of each of the different elements in it. Okay.
And so the rest of the oxygen.
Yeah, so you can either add the percentages and then minus, or just keep going. What happened? What happened? It's 39.
You're gonna change so what is it? This one? That's for mice. It's like
Oh,
It's
but we were
suture.
telling you about the temp. Oh,
Yeah.
yeah.
Yeah, but they can take it
Someone
off.
can take it off.
Just whatever, no.
Yeah, just put it with the ones like a little like.
Okay, you ready?
Like diagonal one way, the diagonal one, but I mean stickers like put on.
Our first thing, what are we gonna do?
You're gonna find your mass of everything.
Okay, so we need the mass of aluminum. Okay, so what does aluminum sulfate look like?
It's gonna have 2 of them by 27.
Two.
Does that make sense? I think I said that.
Two. Okay, so
There's 2 of them and it weighs,
first thing that we need to do is find the chemical formula of aluminum sulfate, right?
oh, yes,
Okay, so what is the chemical formula of aluminum sulfate?
Al2 and then parentheses SO4 3.
Okay, so now that we have the chemical formula, then,
Yeah, you can start adding up.
okay, so we have two aluminum,
Uh-huh.
okay, aluminum weighs,
27.
okay, sulfur, how many sulfurs do we have?
There's 3.
3 sulfur, sulfur weighs,
32.
and oxygen,
12.
and oxygen weighs,
16.
okay,
Yeah, 54, 96, 192. 192, yeah. 342.
342. Okay, so if I want the percent aluminum,
It'll be 54 over the 342 times 100. Yeah, I got 15.8.
at 50.8,
Yeah.
okay? And then for sulfur,
96 over 342 times 100. 28.1.
20,
28.1.
And oxygen,
192 over 342 times 100. 56.1.
okay, altogether that should have to 100. Piece of cake.
Yeah.
Okay, now, if you guys look on your exam, everybody got their exam with them? 'Cause I know you carry it around every day, right?
I thought you were gonna print it out for
I
us.
probably do. You didn't get one, huh?
No, we had like really
bring
really
it.
one.
I have
You have them.
It's because I forgot to bring it.
And did you forget again today?
You could solve it.
I can tell you. So if you look at your exam, I believe, I mean, I may be getting old or something, but I believe there is something in there
About this stuff.
about this stuff,
Because I can do this like in my sleep.
about this stuff, right?
And there's no layers to this.
Oh, there's always layers. I love layers,
Are we
right?
gonna get to the layers?
Well, just sorta, you know, you just gotta think about what it is that they're asking you. So you gotta use a little bit of density, right? So I'll make a copy of it.
I'll read it tomorrow.
I'll make a copy for you here. in a
Oh,
second.
yeah, yeah.
You know how
But
to
it'll
do
cost
it?
you $555.75. Was that?
You know how to do it?
I know
Can't
you
go
like
to
that.
Robin,
Cool.
you know.
Mhm. Oh, you're trying to be smart. No, you proved it.
Because they're like right there in front of their paper.
I see, I already passed the class. I don't need to take it,
Why'd you
right?
take them out of your bag?
Well,
Or
prove
just
it.
have them in your
I
hand?
didn't, yeah, I don't remember.
I don't need to prove anything. I know. Okay. This is-
Let me see how
this is the question. This is
The exam?
Okay, aluminum chloride is 38.35% of, aluminum chloride is 38.35% chloride. What mass of aluminum chloride is needed as a source of 50.0 milligrams of chloride? So this is that layer.
I know, once you understand it, slap in the face. I know, I know. That's your. The other one's not there. And I don't like it red, like. I didn't have. But it's good, huh? That's what she has to bring herself. Maybe I can do it. Oh, no. Just 'cause it's a small one.
Oh, sorry.
It's all there. Are they-
So we're finding the thing for aluminum.
Where have you been?
See, you know.
That's all right, you learn, right? Okay, does anybody else need a copy of the exam? Other than right here?
Just us to know.
Anybody else?
I feel like that's really hard.
Now, you'll get all of the answers from. I don't kill myself. I realized that on one of the questions, I started putting the correct answer on there, like so.
Not that.
Well, so instead of writing
right to left.
instead of writing this way.
Right.
Oh, yeah, they
go right to left.
She's not.
So a person who is left-handed, that is not.
I know, my
No, because for people who write English left-handed, they're like smearing whatever.
Yeah, they
writing.
smear what they
But
write.
if they write Arabic, if they're going the way they're supposed to.
Yeah, I've seen it before. You're like, that they started around.
Yeah, and I'm over
Do
like,
some-
do some, people write like in English, like the other way, like they write it this way.
Oh, that's really hard. I can't.
Let me see.
I say, I wanna. No, she made it and I think it was 114 degrees, like something like 120. So she made it.
No, and when that's why I always hope that none of us get freaking sick. My mom always makes caldos de pollo whenever someone's sick. So I was like, I'm like, oh, hiding it. I'm not like that.
I like it. Thank you.
I like the.
Oh, yeah.
That's my fave. I love albóndigas.
I like it.
I just love cob, like the whole.
Oh, isn't that the caldo de las veces?
Don't they have the corn?
My grandma puts it with the arroz. I don't like albóndigas.
So you write very bad.
Oh, that's hard.
Wait, so what?
It's like an accent,
Wait, so that's.
like an E.
Wait, can you write it?
Or an N with the little thing. If you grab him a flashcard or.
Yeah, write it. No, I can practice with writing. I can read it.
Instead of buying like.
No, do it on the orange one.
Buy like that one.
Wait, let me see the
The new one to
letters.
come out. He said a couple. She said, oh.
Right, good, right, got it, tiny cousin. It's actually like the translate is totally different.
Really? That looks super nice. Like confusing. It's like, it's a lot.
When you translate it, when you translate, like, you use like the old. You know how like
There's newer?
English,
Yeah.
like,
Oh,
English
which
is
one was the one that you were
vowel,
saying?
that's the-
Oh, yeah.
So when you translate in the old,
Oh, I know we said
Wait, so-
pendeja in Spanish.
No, it's not the one.
Oh, you're supposed to.
Yeah, it's corrected to H.
Oh, yeah.
Wait, what is that?
Oh,
Oh, and then you write the. Oh.
oh, yeah.
Oh, she in a case too.
Cheese.
Fancy.
Thank you with the text.
I was dead.
Oh, yeah, right, my elbow.
Oh, Habibi, you ready, Habibi? Buy your
Oh.
tags on time? Or buy your results?
Yes, yes.
So
I would have waited too. It was maybe fine, but it was like 1,000. But
Like, when you guys write, is it have to like, you write? And if it's quicker, it's like weird.
It feels wrong.
It feels wrong. It feels like this thing.
you guys started the group? No. Ask her if she started.
Have you remember when the teacher would call you out for not eating?
What's your being?
Were we guys doing at the time? What was the holidays?
Or
Like why? They have a holiday whenever. Oh, yeah, it's in
Ramadan.
yeah, Ramadan.
Wait, you do that?
No, I was telling her.
Yeah, isn't it like,
Oh, yeah.
yeah, because isn't there like a certain time where you need to eat?
Like
Like,
I said, like got 1 month.
It's from 4 a.m. all the way to
That's your time frame?
no, but like, when's the time where you
Not even
really
drink
eat?
water.
Oh, from 8 all the way to
So what is
8
it?
p.m. to
You guys could eat, but you can't eat in the morning.
They have to whistle.
So it's 8 hours that we can eat and 16 hours.
They have to eat when the time is.
So do you like grub? You like eat as much as you can? So what's the reason? Is there a reason why you guys don't 10,000 freaking double
There's a lot of reasons why.
Isn't it like mostly like yours? Cause like what for Catholics they sacrifice, right?
The only thing was the 10 days.
Oh, okay.
I was a baby one too.
What did you like? Sacrifice? And have to eat for
But to eat, is it animal to eat? Oh, to eat. You know the thing I can't do? If I see a dead, if I see someone kill an animal, I do not do it. I see my grandma kill a chicken. I know, it's because it's already made. I cannot see it being killed. I feel like I can't see it being killed because it's so like I cannot. Really, I used to eat goat. When I never knew what it how they killed it, and my parents got one. And it's the head and everything. I would eat a lot. From that day on, I voted one time, and it was. They told me it was breast.
No, well, that's what they told me. And then I walked outside and I said,
We'll go into the store and you buy.
But it's already made. I didn't see it. I don't see it getting killed. I don't want to see it going.
You know they kill those.
I've never. Yeah, but I try to get it started.
As soon as you gotta get like a meat sharp knife.
You know what I made?
My boyfriend kills your grandma. Well, not a girl, but she kills the freaking big old dogs when he goes hunting. He kills a deer. He like skins them when I'm looking for.
Oh, you're from Yemen? Yemen, you're from Yemen?
I've heard that. Were you born there or? I seen it from a show. Okay, I've heard that. Now word in the
So.
what show? Yemen.
Wait, how do you say it? Like,
Come on, we're not gonna say anything bad. We're just learning, dude. We're fascinated. Yeah.
And last thing.
I casi todo, güey. Chíñalo.
17 minutes.
Don't worry, don't worry. Cassie's going to.
My first name is.
Oh, I kind of got it. I kind of got it down there. We tried saying it.
you know?
She's so.
But she's Indian, huh?
Yeah.
She's Indian.
Ah.
You want by yourself? You want by yourself? Really? Well, did you not see his friend, your best friend, where you go to? You went to Dubai, didn't you?
Who went to the?
This is not.
Holy shit. So how much does
The ones
that
that you
run?
like.
Like one of those?
$100 is like
Get it, girl.
You hear him?
$100 here is 100,000 over there.
this is
We're
like
rich.
Sorry.
That's a lot of money.
I said we're learning things.
What do you buy?
I think they don't
car.
learn it. What is that? Oh, what is that?
Over there?
When I retire.
Why do you buy it?
Airport. It's illegal here, isn't it? Yeah, it's making here. You know, it's like-
My boyfriend wants to give me free. Was he born there too?
Oh, so he was born here and he went over.
And he was raised over there?
When he was little though. You guys don't live with him.
No.
Is it your dad and his mom? Oh, yeah, honestly, okay, I don't know what we wanted to ask. I don't wanna. But like. Say yes. How are you? Is everyone? Is everyone related? Okay, how is it when you guys are related? Okay, yeah. Oh, but like, why is everyone, how do I, like, people always are like, oh, we're all related. I'm like, well, do you guys all come as a family then? You guys all come together?
Yeah, that's for like an hour.
Oh,
Are they gonna do their right here? Like a good job?
because I think you guys are saying here though, or that's why. Oh, shit, okay.
So presentation is good.
The parody is
Okay, we were saying that we could come, or we could meet up in Louisville on Thursday or Friday. I can't do Friday. Or Thursday, what time do you go to?
Has anyone used it? Are they gonna do it? No, are they gonna do it? That's theirs. They're just gonna- they're going to- they can get the party.
I think we should just go. Oh, but it is.
No one's started. Are they started at all? Are you guys gonna do the party? The
So
party?
you don't have to be prepared. I'm thinking that. Why don't we just like each will put our own part, like, we'll have to come up with it together.
That's what we were saying. That's
Or
why we're
the
doing
videos
it
today,
today.
because they were so hard to meet up today.
Or tomorrow, but we're
So we
gonna
can
do
have this one. So that's what I'm saying. So we don't have to like.
I think it'd be cute to do that. Like on iPhone. If you have our snap. Well, you know how when you go on FaceTime,
Where's Destiny?
you could change your haircut.
She left, she went home.
She went home.
Why was here stuff?
She said,
Wait.
wait, Destiny's up?
Oh, yeah, she went home.
Oh, she's not, is she coming back?
I was like, oh, yeah, let's go, let's just stay. We could just text her. But I'm thinking like, we'll come up with our.
I don't think she's near you guys were gonna. see.
Yeah, we
No, we
asked
asked
her.
her.
We put it in a group message.
And she literally said, we got to have sex.
She was the first one to say.
Maybe she would.
Yeah. And I was like, same.
I know she said she worked last night.
Oh, yeah, she said that she didn't have enough conversation.
We can.
What did you say about that? What did you guys have? Like for iPhone?
I don't know.
Or we could just do, well, I don't have to go out of our way. Because I don't know how, like, I don't know how.
We can
That's the
record it on
easiest
our
way.
way.
Yeah, that's the easiest way, because then we don't have to go, we don't have to figure, we don't have to edit.
So we can do it emojis and we can just record it on our phone.
So we'll come up with.
Because we can do.
Yeah, like
one
I was
person
doing
can
it.
do
Like,
whatever
this
with
is
their
so
back fingers,
accurate.
or-
I think everyone can do more part. You don't even see your face.
If I wasn't working, she would have worked.
I know, I'm not super accurate.
Yeah, that's what I'm saying. Not the hair though. Maybe you can put on my snap.
I was thinking maybe, I don't know if you guys want to, just give one person certain parts to do in the group. Like,
Oh my
for
God,
example, I
you
could
can say
I could do the whole slide.
Let me see. The ball right now.
Well, I have to go. I can just do it. It's exactly the
We
same.
do like this. We do like exactly like you. Can I make it? Let me make it. See, that's.
We gotta make it.
Make it just like. Hey, don't put your hair. Don't forget the Invisalign.
Yeah.
You never take them off.
I don't know, we'll figure it out.
Yeah,
Look
that's
at you
it, right?
guys. Yeah.
We'll figure it out.
Okay.
Did you get snacks?
Did you bring us?
Okay.
No eating.
So, sorry, I had to unjam the printer.
More stuff.
Guess I'm good enough.
What?
Trying to get your undertones.
Okay, so first off, we have 50 milligrams. Okay. So this is the part, right? We want to calculate the whole, right? Okay. Okay. So we know that in aluminum chlorate, this is going to equal 13.5%. True. Okay. So solve for the whole. So we multiply both sides by whole. Then we divide both sides by. Percent.
We're gonna need another example.
You got no lips.
I have no idea how to do this. That's not.
Sometimes it doesn't matter how you get there, as long as you understand how you got there. So then, we get whole equals 8.5 times 0 kilograms. So then
Sorry.
or you can get fancy because you know what that is.
I know.
Percent. Milligrams of chloride. With your units, the whole is 50 milligrams, right? Okay, everybody see that?
Yeah.
Yeah, it'll be the same unit that you have.
Wait, where's the answer?
Because you cancel those units out, so they have to be exactly the same. Now, so it could be any unit in milligrams, as long as you're consistent, as long as they're the units. Same units. So the beauty of molar mass, right, is that it could be grams over moles, right? Which is going to be equal to milligrams over millimoles,
I wish it was a little bigger.
which is going to be equal to kilograms over millimoles. Okay. So they're gonna be equal to each other regardless, because both of those units are on top. So gram is a base 1 unit, right? And then mole is a base 1 unit. Well, kilograms is 1,000 times divided by 1,000 kilomoles, right? So it'd be 1,000 times more on top. Okay. So that, always keep that in mind. Okay. Questions? Concerns? Yeah. You got 130.
And then this, I don't have work Thursday, but I want you to do the other. Yeah, I know it.
What's that?
Unless we
Three?
need to
Yes, I
online,
did.
so we're not gonna- just for this Thursday. And then she has an appointment on Friday.
But let me see what's on this one.
Okay, questions, concerns,
No, March on Saturdays.
go overtime. And then that's the thing, 99.9999% of the time, you overthink the questions. Or you overthink so much that you scare yourself from answering the question. Right? That's most of your cases, because I saw that how many guys need to explain. I just want to throw stuff at you. Oh, man. Never leave you blank. Put something.
I feel like if somebody walked in this classroom, they saw the emojis, they looked around, I think they would.
Say again. You could have done that too, right? But then it's ratio, right? This, that's all you're doing over here is by doing this, then you're solving the game, still solving this problem, right? Does that make sense? Yeah, so still gonna be the same ratio. Because what you're suggesting is, this is what they're suggesting. So they're gonna do 50.0 milligrams over a whole is equal to 38.35 over 100. Well, guess what? That's exactly the same way to do it, because now you're just bringing it over, and the ratio, you're still gonna have to solve for what your whole is, right? So it's just a ratio. Works the same way. There are 50 different ways of getting to the same answers. I just showed you two. Now, when you're able to see how to get to them all different ways, then you master it. Build in your learning. Okay? Questions? Concerns? Okay, so let's move forward. I got more. So your practice final is printing right now. You have a question?
How many questions are on our final here?
So I believe there's 50. I think it's 50 exactly. 50 or 55. I have to look which one. Yeah, I have a couple. I'm the only instructor, so I get to pick a lot of things. They're both pretty easy. Can you choose once you get there? Okay, our next topic is empirical formulas. Okay, now empirical formulas, don't overthink it, right? You're thinking, you want to be simple, think simple. Do you guys remember doing the lowest integrals, lowest common denominator, stuff like that?
Yeah.
Okay, so in this case, it's kind of like the lowest common denominator for chemistry, right? So if we have a chemical formula, like C4H10. guys see that peak?
I'm already ready. I can go probably as soon as I can get
Okay, the empirical formula will find the lowest common denominator for these things. So what can I divide this by and still have a whole number? I can divide this by 2. If I divide both of these by 2, I get C.
Yeah, but honestly, you can skip from here. On board.
Oh, I would get C 2 H5. That would be the empirical formula. Simple? Okay, so now, again, this would be the molecular formula, this would be the empirical formula. The empirical formula tells us empirically what we have, right? It doesn't tell what we have molecularly. These two behave differently, they're two different compounds, okay? But you want to distinguish between the empirical formula and a molecular formula. Okay, molecular formula is the way it actually is. Empirical formula is the simplest way that we can do it. And the reason why we use empirical formulas is because when we use instrumentation, it tells us relative to what we have, right? So it'll tell us we have 2 carbons to 5 hydrogens. It can't distinguish between 2 carbons and 5 hydrogens compared to 4 carbons and 10 hydrogens. Okay, so that's what the empirical formula is for. It's basically for instrumentation. But you've got to learn how to use it, because if you go into forensics or anything along those lines, right, and you're doing labs or something like that, it'll tell you the ratio of carbon to hydrogen, right? That's what you're seeing. It's not going to tell you. So it's not going to say it's going to be 4 to 10. It's always going to say 2 to 5. Okay? You guys understand? So, but you can use that reasoning to sit there and try to figure out other things out, right? So you know somebody's been poisoned, right? You want to figure out what the hell they've been poisoned with. So you're going to get a ratio, right? So you're going to get the empirical formula. Well, it has this many carbons, it has this many hydrogens, it has this many nitrogens. So you're going to be able to sit there and say, okay, so what has this ratio, right? That we know that kills people, that can get they come common contact, right? So you'd go through a list and sit there and do it. Or you'd sit there and isolate the chemical itself, which there are different ways of isolating it, and then test it on other reactions to determine specifically what it is. But the empirical formula gives you a good starting point. Okay, that's the reason that we use it. Most people say, why do we have to do this? Well, it's because it's used in analysis, right? That's the reason why you have to learn that. And we all assume that either you're going to be if you're going to be a PCA, like PCA is pesticide control. Okay, it's a certified pesticide control person, whatever, right? So they actually use it when they determine what poison they're going to use to kill a bug, right? And so if they fuck it up, then they can kill people too, right? So we want to make sure that they don't. So, okay. So let's see how we can use these. So let's assume that we have this compound. Tell me the empirical formula.
Yeah.
So are we
Is that
always?
true?
Yes.
I can divide by 6.
I was just gonna.
So yeah.
C.
So
Oh,
then-
6. Or what is it?
I see.
Or the biggest.
No, it has to lowest common denominator, right? Lowest common denominator. So we don't want to be able to divide it by anything else, right?
Okay, yeah.
But
So
I
what
would
is
agree.
it?
So we divide this by 6. So then if we divide this by 6, we get 1 of these, 2 of these, and 1 of those, right? Yeah, see it?
Yes. Another one.
Want another one?
Yes.
So let's say we have.
Exactly. So. By 3, P4, F. Yeah, P4, F.
I can divide by 3.
Yep.
P4.
F.
Okay. Piece of cake?
Piece of cake.
Good. Okay.
Don't have layers. We definitely like this. It's almost time, either way.
Well, that's the reason why I give you more, right?
No, no,
I have to
no,
give you
no,
guys
no.
something to think
I
about,
should get
because
it.
then you feel weak and soft, you know, I don't want you to feel weak and soft, I want you to be strong, right? Okay, so how can we use this?
No.
Right?
No.
This is how we use it, okay? So I'm gonna go through this problem. Everybody has this problem up there?
Yeah.
Good. It says a sample of pure compound. So we're talking about a compound, right? It's made up of 1.61 grams of phosphorus and 2.98 grams of fluorine. Find the empirical formula of the compound. So this is an example. So at the end of the day, the instrument tells you that it had 1.61 grams of phosphorus and 2.89 grams of fluorine. So we need to get this. We know that this is this quantity or is this mass? It's quantity, right? And we're given mass. So what do we need to do? Right? So I should say, let me rephrase that. So empirical formula is quantity, right? It's relative to each other. It's quantity relative to each other, right? So, and we're given mass in this problem. So what is the first thing that I'm going to do? Okay, so let's look at this, right? No. I didn't say anything. Don't look at my look. My look didn't say anything. Okay, so what are my givens?
We're given 1.61 grams
of phosphorus.
Of phosphorus. So I have 1.1, and I will flip it over here in a second. 1.61 grams of phosphorus. Phosphorus is B, right? Okay, and then what is my other given?
2.98 grams of fluorine.
2.98 grams of fluorine. Okay, right? Okay, so if I have mass, is it this mass? What do I need to do to get to quantity? I want to get to moles, okay? So how can I get to moles?
Avogadro.
Are you sure?
No.
I have mass. Okay, I use the molar mass.
There you go.
Okay, so what is the molar mass of phosphorus?
Oh, of phosphorus? Where's it at? 30.974. It could be 31 round up.
31?
Yeah.
So 31 grams. 1 mole. So didn't I just get the quantity? Okay. Okay. Somebody do that math for me?
I know.
Heavy lifting?
Like how? Yeah.
We're going to try it. Figured out, trying to get this.
I got 0.05.
0.51. Anything else afterwards?
I got, it was 0.051.
You got, okay,
Did I do something wrong?
0.0.
Yeah.
0.051.
It would be moles.
There's no number following it?
Oh, yeah, 935.
935. Okay, and that would be, okay, so
Yeah.
sig figs, how many sig figs should I have? You guys can carry the weight.
3.
I should have 3 sig figs, because this is 1, 2, 3. So then 1, 2, 3.
0.05.
No.
Wait, oh, yeah.
Because this is a 3, 5, right? So we look at this guy, that's 1, 2, 3. This is a placeholder, right? So we use this guy. Are we rounding up? Or are we gonna leave it alone? Okay, so then it should be 0.051. Okay? Fluorine, what is the molar mass of fluorine?
It's gonna be 19.
Okay, somebody do the heavy lifting for me? Now let's calculate.
Point T68.
1.56.
842.
So how many six do I need?
3.
3. So
Point
at 8.
1.15.
So this gives me, now, this gives me quantity to quantity, right?
Yeah.
But now I need to compare them to each other to get the empirical formula. So what I'm gonna do is take the smallest number. What number is smaller? 0.0519 or 0.157? Okay, so. I decided that.
Right?
So what I'm gonna do is we're gonna divide both of them by that same number. This one by 0.0519, because this would give me 1. So if I have 1 phosphorus, then how many fluorines do I have relative to that phosphorus? 0.0519. Okay, so I divide them both. So this would give me my phosphorus, so this would be 1 phosphorus.
Get more.
And then how many of these do I have? 15.7 divided by 519. 0. So it's 3.025, right? So in other words, this number is really close to 3. So we're gonna round it up to a whole number of 3. It's only have whole numbers. So this guy will be 3. Fluorine. So my empirical formula would be P F 3.
Oh, it's it.
Yeah. P F 3.
How else are you gonna figure it out?
Okay,
Exactly.
you guys see that?
Yeah, I see it.
Okay.
So you take the smallest number and
Yeah.
divide?
That's right.
Okay.
Because you want the smallest number to represent 1, right? If you divide by the bigger number, then you're never gonna get a number that's gonna be 1, because you can only have whole numbers for your empirical formula,
Okay.
right?
Yeah.
Okay?
Yep.
So. Everybody got this?
Yeah.
Pack up yet? We still got more? I got you for a minute. I'm gonna use every minute. I got 5 minutes left, so don't give me my last 5 minutes. Because technically you're at 12:05. That's when you guys are officially out. I've been too nice. I didn't realize that.
I'm still out.
Okay, I have 7 minutes left.
It was fine.
Okay, so here we have percent mass, right? So nicotine is 74.1% carbon, 8.64% hydrogen, and 17.3% nitrogen. Okay, so then when you guys have percent, think of it as a whole. So if I have a whole being 100, right? So if 100 grams of nicotine, how much of it is going to weigh? How much of it is going to be carbon? How many grams are going to be carbon?
So you have 100
If I have 100 grams total of nicotine,
on your 74.
74.1 grams of it is going to be carbon. How much of it is going to be hydrogen?
8.64.
Okay, 8.64%. I mean, 8.64 grams is going to be hydrogen. And then how many grams is going to be nitrogen?
17.7.
Okay, now that you know that, find the empirical formula. Okay, I'm going to get the practice. Hope we get this. Can I erase this? Everybody got this?
You're gonna get us ready. Joe. Did you start with that? Oh, no.
Oh, and our practice. No, but
Getting-
he's giving to get us our other exam. Like,
You mean the exam
our group exam.
Yeah.
So he's gonna put a practice exam.
for the final? I don't know if he either did it or he's gonna get it right after. It's not as cold as they're just both.
So I'm gonna do it. Am I what I'm saying?
It always does that.
This is just for the backup.
Always.
Like,
5 hour course.
kids are.
Right.
For persuasive, you're trying to persuade
People to think that they should be younger than teachers.
I don't know, I have today.
So you guys, are we gonna go work on our thing, right?
Yeah. But after tutoring,
I'm sorry, what?
after tutoring, we're gonna work on it.
So you mean think I'm about to stay after tutoring?
So we stayed yesterday. We tried to stay yesterday.
Yeah, I'll work on it.
Okay, that's fine.
That was just like 5 o'clock?
No, we're here.
Okay.
But actually, like that one.
Who's that, Leah?
Oh,
Oh, okay.
That's fine.
That's bad, huh?
Yes, sir.
We forgot to know first.
I don't know, nobody really knows.
Oh, you're okay?
Your motto, whatever. Your motto. Your birthday? What is it?
Yeah.
Guillermo.
Okay. Chimney.
Oh, yep. Thank you for that. That's the same thing. I always flip like this.
Okay.
Yeah. Tell me what's the-
So you can multiply that one. So you guys, you already started off with grams, but you're trying to get the moles, so you get. Yeah, from grams.
So you're gonna multiply by that.
So basically, you're saying.
We're confusing you guys together again.
Oh, yeah.
Oh my gosh. The guy that you can. It's like, she's like, the one in Macy's, but where? It's like, you know, it's actually shoes. And when he's out there.
Okay, you guys have answers for me? Okay, so where are we gonna start at?
Carbon.
So we're gonna start with 74.1 grams of carbon.
Yes.
You know that carbon weighs 1 mole of carbon over 12 grams. That's gonna give us,
Are you doing whole numbers? No. They're not? Oh my goodness.
okay. And then hydrogen, we have 8.64 grams of hydrogen. Okay, and then.
So this is only worth 15% of our grade, right?
Yeah, but if you have a 70 or less, 15% of that, so you're already at 70 now, right? Let's just say by luck, you're at 70 right now. Right?
By luck.
By luck.
What
By
about
luck.
above 7?
By luck. Well, if you're above 70, well,
Then I'm
you're
good,
still.
right?
Wait, but that's if you're at 90, you're good, right? Because you take 15% off of that, right? So subtract 50% from 90, okay? If you're at 70, subtract 15% off of that.
What about our, okay.
Right, yeah, you still haven't done the presentation. You still have the presentation, you still have the exam, so. You still have your cover letter.
So you're still gonna pass?
Because it's the final.
It's a
It's all combined. So we're taking the 4 hours here in class.
We're gonna pass.
I
And I'm gonna
know.
go to 7.
Are we gonna have break?
Try to bring
Yeah,
home.
so you have three choices. Okay, so let's go ahead and finish this problem. And then we'll talk semantics. I'm getting the drift here.
Oh, I got that one.
So, smallest number. Okay, so we're gonna divide everything by 1.23.
Similar to our final exam.
Yes,
It probably is our final exam, huh?
very similar to your final.
I already got the first one right.
You got one right?
I got one right. Right.
We're gonna go over everything. Anything that you don't get a chance to go over, like so far you've gone over everything, right? Pretty much everything except for, there are two major topics that you're gonna be going over. We'll be going over those tomorrow. No. This isn't the practice. It's very similar. So the ACS exam, I cannot take a copy of. So it's like a standardized test, right? So, and so I can't make a copy of it, so I can't use those questions. But what I did, I try to find questions that are gonna be similar to it. Don't overthink the questions. It's your biggest problem. Again, your biggest problem will be overthinking the questions, right? You saw earlier what you guys did. A very simple question, but you overthought it, right? That's typically how you mess up on this test. Right? Okay, so when we did this, what will we get here? How many carbons?
5.
How many hydrogens?
7. And then
And one nitrogen. So then our formula is going to be 5,
by the
7,
smallest number. So when is that back? So like obviously.
yeah, you should be able to, at this point, this should be it in terms of empirical formula, right? Because one of them is 1.
So basically it's simplified, right?
Okay, yes. This should be it. Okay, so we'll pick this back up tomorrow. So tomorrow is going to be a crazy day.
So 30-minute break.
So we got 2 major things to cover. So, and we'll be finishing up this chapter 7. So 7, 9, and 9 is going to be a really quick version of 9.
Okay, so
And then
should I
10
come tomorrow?
10 is the more important.
Should I? So like, there's like so late now, and I want something to see you.
You can actually push it back.
Just tell me about it.
What time
I would prefer
what time do you reach the post office?
So we can take-
I usually snack at work. I usually
I would bring, except for the pencil. You gotta bring it in. You'll need a
at that
calculator.
time.
I need
You
your.
can take it out. Just come to-
I'm ready to walk in.
So,
I'll meet you later.
okay, there was something I wanted to say. So, you guys are in the this is the last week. This is it, right? This is it. That doesn't mean that you tap out this week. This means that you study your ass off this week, right? You can't take anything for granted. Don't assume because you have a 70 that you will pass the class, right? Because if you fail, let's say you screw up on your presentation, right? You end up getting below a 70 or less, right? So that's hurting you, right? Immediately, because that's 15% of your grade, isn't it? Right? Okay, so you look at it, if you're at a 70 now, or a 75, or whatever, right? And let's say you screw up and you get half those points, right? Half of 15 is what? 7.5. So subtract 7.5 from 75, right? That's 60 something, right? So that brings you down to a 60. Let's say you don't get shit. Let's say you get a F on your final, right? No, you don't know that you're gonna get it. And don't come in with that attitude, come with that, right? You tell me that, I'm just letting you know, no. You come in with that attitude, guess what's gonna happen, right? You're gonna fail, because you've already decided that you're gonna fail the class. So then I expect to see you gonna fall, right? You need to come in with an attitude that you're gonna pass this class, right? So that means you're gonna bust your ass, you're gonna study. Right?
Bust down.
But that's a piano.
Bust down.
And don't overthink the questions. Sometimes the simplest answer is the right answer. Okay?
I don't believe it though.
No.
I do get happy on that.
And then you just told her, the simple as that.
Exactly, you talk yourself out of it. I'm looking at some of your exams, I'm like, damn, this will be an easy question. I shouldn't even put this on the test, right? And then I'm like,
All of us got it wrong.
holy shit. And then like, you're doing all these crazy things, like, how the hell did they get that? I mean, we never even talked about anything like that. I'm like,
So, all right, for our exam, I'm gonna do a test question, so we can look at our own exam, right?
yes, you can look at your old exam.
Okay, so for the test correction, is it the right answer, why it's right, and
So,
Oh,
it's,
really?
you look at the wrong answer, right? You tell me why that wrong answer is wrong. That's the first thing, right? Then you tell me the correct answer, and then you tell me why that correct answer is correct, right? And you can't tell me that, oh, it's correct because such and such says so. You tell me something like that, I'm taking points. Yeah, no, I don't want to hear that either. I want to hear why it's wrong. Like, 'cause obviously, it's either calculations or it's because you thought the concept. Like, say, for instance, we were talking about homogeneous, right? So you had a question on homogeneous. You said homogeneous was salt and pepper, right? Well, you know, homogeneous means what?
The same.
The same, right? Salt and pepper are not the same. They don't look the same, right? So that's clear why you got that wrong, right? So you tell me why that's wrong, okay?
Yeah.
Yes. No, you cannot use these corrections on the
Are we
final.
gonna have the cheat sheet available for the test or for the final exam?
No, you will get on the final exam, you will get a periodic table. You can't use your own periodic table. You will get a periodic table. You will get a little table that has all of the equations that are going to be needed for the exam. Believe
get
me,
a tattoo?
all you need is right there. It is the most simplest exam. What happens to students is that you guys talk yourself out of the right answer. Like, I'm gonna give you an example. This is the one that always gets me. I gave you the example at the very beginning. Real quick, it's always on one of these tests.
So,
Every
are you
time.
telling us the answer to the test?
What was that? Okay, so tell me which one would represent an element. Okay, this is A, this is B, this is C. Which one is going to represent an element?
A.
Okay, that's it. You know how many people will sit there and give me this one, right?
That's a mixture, right?
Right? This is a mixture, right?
That's a
This is a compound. That's a diatomic element, right?
Period.
So, let me tell you like this, you will get a question very, very similar to that question on every
Me too, take
exam.
a picture.
Every exam. But I'm telling you, in my class, 90% of the students miss this question. And the questions are all like this. So if you're thinking about 90% of the questions like this, it's because, again, you overthink the damn question, right? You don't think about what you know. It's just that simple.
Okay.
In most cases, they are that simple.
So you mean to tell me
How
that
to
you
interact,
can
how to interact with an element.
So there are, depending on the different exams, there are different years. So we collect the years. I write a couple of years, so I'm not giving the exact exam.
They might be able to have the hardest one.
No, they're all not. Again, I bet you, if you had an opportunity to look at it again, you'd be like, oh my God, I can't believe I missed this question. Oh my God, I can't believe I missed this question. Oh my God, because again, you often will overthink the questions. The simplest answer is usually the right answer. Don't overthink. Sometimes they do try to get tricky, but then read what they say. Like for instance, they'll say, again, which one was an element, right? So your first thing is, oh, element, oh my God, element, where's the element? And then, oh yeah, element, diatomic. This is tricky because this is a diatomic element, right? That's the tricky part of it, but you know that it's an element, right?
Yeah.
Okay.
Okay.
It is time, yes, that is also the harder part. It is a timed exam. You're gonna average, I think it's like
50
a minute per question, right? But
Oh,
again,
I did
wait,
5
just relax. Again, they're not multiple part
Oh, yeah.
questions. They're not like mine. They're very simple, simple questions. Okay, like for instance, they like pH a lot. So pH is equal to the log minus the log of the concentration.
Do we do that?
We haven't done it yet. You'll be doing it next week.
Wow.
Don't worry about it. You'll be doing it here soon. Yeah. I have to build you up to it. Just relax. I'm getting you there. Okay. So they love this question, right? Now, the thing is that they'll tell you the pH of a solution is such and such, right? And then they'll say, and they'll give you the pOH, right? Is 7. And then that means pH has to be 7 because altogether these two have to add up to 14. I'm going to tell you that, right? Now, but they'll give it to you in the answer and they'll say, what is the pH, right?
So this
But they
is
just
the
given you
pH
the
is 8,
pH.
it's gonna be 8,
No, if it's 7 and 7,
but
right?
if it's 8, it's 8, right?
Yeah, if it's 8, it's 8, right? Sometimes they'll give you the damn answer in the question and you're like, okay, they'll get this. It's not, literally, there's 2 questions on that exam that they literally give you the correct answer in the question. I'm like, they got this. They got this.
So you just told us like that one is the answer, so.
I'm just saying this is an example. I can't remember the exact question. Okay? So don't freak out. Breathe. Okay?
Yes.